Assalamu alaikum all of you. I'm Hadika. It's basically the continuation of the previous lecture. In the previous lecture, we have covered the basic terms like atom, subatomic particles, isotopes, and orbits, nucleus. In this lecture, we will cover three topics. The first one is the relative atomic mass, second one electronic configuration, and the last one is isotopes. Okay, so what is relative atomic mass? Mass. Let's talk about it. It's a vector quantity. It's actually the, you can say, magnitude of a body that is inside the object through gravity. One more thing, when you say it's atomic mass, so it's related to atoms. So that mass, which is an atom, is atomic mass. What is relative atomic mass? Making a relation with any other atom of a single atom is known as the relativity. So why will we relate it? As we all know that the mass of an atom is too small to be determined practically. So how will we know that what is the mass? So we have to use certain instruments that will be helping us in the determination of the atomic mass of the various elements. And so how to make that a scale, how to make that instrument. So we took an element carbon 12 for the scaling purpose. So we actually relate each and every atom with carbon 12 atomic mass, and we define it as that the relative atomic mass of any element is the average mass of an atom of that element as compared to 1/12, 1/12 or 1/12. You can say the mass of an atom of carbon 12 isotope. What is an isotope? An element which has different mass number or neutron number. So basically, carbon 12 standard is used to relate masses of individual atoms. The mass of an atom of carbon is 12. Okay, what is mass? Atomic mass? Atomic mass is basically neutron plus protons. So the neutrons and protons in carbon atoms are 12. So its atomic mass is 12. So whenever we have to relate any atomic mass, so we have to relate it with 1/12 of the carbon atom. When we compare atomic mass of other elements with carbon 12 atoms, they are expressed as relative atomic masses of those elements. Most elements have more than one isotopes. So we have to see the abundance of the isotopes as well. But in this relative atomic mass, we take that isotope of carbon which has 12 atomic mass. So it will be easier for us to relate it. Carbon is a very different element. Its nature is really different. Its nature is that different that chemistry has its own domain of organic chemistry. It contains molecules only from carbon and hydrogens. So hydrocarbons have their own domain, and rest of all the atoms are in inorganic chemistry. So carbon has got something in it. So you can say it's a captain of all the elements. Maybe because of its nature of reactivity. If okay, it's for the next classes. So we were talking about the atomic mass. Atomic mass is the simple mass number, is the sum of protons and neutrons. Relative atomic mass is the atomic mass when we relate the atomic mass of an individual atom to carbon atom. And atomic mass unit is actually AMU, and we say that we express atomic mass in atomic mass unit, that is AMU. So it is this, and it is really impossible to know the mass of an atom, so we have to relate, we have to make a scale. Atom is so small that Avogadro's number says that it's really small. In fact, one atomic mass unit contains 1.66 10 raised to the power minus 24 grams. Like these atoms, like minus 24, like 23 zeros are there. Are you getting it? So it's really hard to compare or to know the mass of an atom. So we relate it with other elements. Most of the elements have more than one isotopes, so we see the abundance as well. You can say that carbon-12 was chosen because the chemical atomic weight based on C12 are almost identical to the chemical weight based on the natural mix of oxygen. There is a link share here, you can Google it. It's they have really well defined the relativity of atomic masses with the carbon-12 atom. And one more thing I was thinking to tell you is that the difference between atomic mass and relative atomic mass. Atomic mass is the total mass of the nucleon present in the nucleus. Nucleons are basically what? Protons plus neutrons. While relative atomic mass is the ratio, or you can say the average mass of atoms of an element to 1/12 of the mass of carbon-12, we are going to relate the mass of any element with carbon-12. This is the relativity of the atomic mass. Atomic mass is calculated for each and every isotope separately, like hydrogen, deuterium, tritium, carbon-12, carbon-13, carbon-14 का individually we will calculate the mass. But relativity में what will we do? We will calculate the relative atomic mass by percentage abundance of all isotopes. Like कितने type के isotopes are abundant in the nature. इसके according we will relate. So carbon 12 के जो isotopes हैं वो बहुत ज़्यादा है कंपेयर टू कार्बन 13 एंड 14, इसलिए कार्बन 12 को इस एज अ स्केल भी वी कैन से दैट वी हैव चूजन इट. नेक्स्ट, atomic mass is a directly calculated value, not a relative value. Obviously individual है, separate है, so why will we relate, while obviously वो कार्बन 12 एटम से we are going to relate it. एटॉमिक मास का यूनिट है एटॉमिक मास यूनिट AMU, while relative atomic mass का कोई यूनिट नहीं है. It is a relativity, it is a connection, it is a comparison of a ratio, it's a percentage. So this is about the relative atomic mass. So if it comes at what is relative atomic mass, so you have an idea that it is the relativity of the masses or the relative atomic mass of an element or of any element is the mass of one of its atom relative to 1/12 or 1/12 the mass of one atom of carbon-12. कार्बन-12 आइसोटोप्स बहुत ज़्यादा हैं नेचर में, इसलिए कार्बन-12 का लिया गया. कार्बन-13, कार्बन-14 आर देयर बट इन अ लो क्वांटिटी. So if you have to relate, take the relative atomic mass, so you have to take the average mass of an atom, you will multiply it with 12 upon 1 mass of one atom of carbon-12. This is the formula, we are going to use it, but as you know that you are in 8th, so it is just an introduction of the relativity, so it's enough for this class. Okay, so next topic after the relativity of the atomic masses is the isotopes. So what are isotopes? Isotopes are basically the, you can say, variety Allah Ta'ala has provided, or the variability of a particular chemical element which differ in neutron number and consequently in a nucleon number. their neutrons differ. So obviously atomic mass differ karega. Atomic mass kya hai? Nucleon number, so it will differ. So all isotopes of a given element have the same number of proton but different number of neutron in each atom. For example, let's take the example of hydrogen isotopes. Protium ko, let's see, it has only one proton and one electron, no neutron. Deuterium has one neutron and tritium has two neutrons. Let's take the example of another isotopes. Carbon 12, carbon 13, carbon 14. See, neutron numbers are different. Here it's 6, here it's 7, here it's 8. So number of neutrons are different. It is a variety of an element and it is called isotope. When we compare isotope abundance, we say it is the relative atomic mass. So it's a different thing. Okay. Next isotope we have is the isotope of oxygen. Like here you can see that there are 8 neutrons. Here there are 10 neutrons. And okay, this is the periodic table I have attached. Here this periodic table is giving a very good, you can say, identification from IUPAC. IUPAC is an organization which actually give namings to the elements, and they are really working on it. So the black number indicates the isotope is stable, the red indicates isotope is radioactive. Radioactivity is a different term. I have shared a link. Please Google it and learn more about it. It is not a part of your chapter. I'm just introducing the names. So these are, it's a way of representing periodic table worldwide. Okay, so isotopes are the elements which have different neutrons. If they have different neutrons, so they will be isotopes. जितने isotopes की type होगी दुनिया में, उसकी वजह से उसको calculate करके हमें पता चलते हैं atomic masses. और atomic masses की जब हम percentage लेते हैं तो हमें पता चलते हैं relative atomic masses, right? So this topic is almost introduced to you. The neutron percentage will vary isotopes, will give the variance of isotopes, and उससे atomic mass change होगा. See here the atomic mass was changed. जब देखें प्रोटियम का H1 है, ड्यूटेरियम का atomic mass H2 है और ट्रिटियम का atomic mass H3 है. इसकी जब रिलेटिव अपेंडेंस को हम कैलकुलेट करेंगे कौन सा मास ज़्यादा प्रेजेंट है तो वो रिलेटिव एटॉमिक मास होगा. So this was all about the introduction of relative atomic mass. You can Google for more videos. Okay, now an atom is a neutral because it has got equal number of electrons and protons. If it does not have equal number of electrons and protons, any electron is lost by any atom. So after losing electron, it will become positive in nature because that electron is going. See, it's going, and has gone. Now, if that electron, I'm extremely sorry, I've got an offer from Edwil. Okay, if this electron is gained by this atom, so it will gain this electron and it will have a negative charge, and after being neutral it has become negative. This is called anion. Okay, okay, I'm so sorry I forgot to share this. These are some types of isotopes. Okay, this is hydrogen. These are the masses, mass difference, abundance. सबसे ज़्यादा प्रोटियम प्रेजेंट है C. Okay, this is carbon, carbon 12, carbon 13. सबसे ज़्यादा carbon 12 present है C. And then nitrogen 14, 15. सबसे ज़्यादा nitrogen 14 present है. 16, 17, 18. सबसे ज़्यादा oxygen 16 present है. तो उसके मास को फिर कंसिडर किया जाएगा कि ज़्यादातर ऑक्सीजन का यही मास होगा, ये एटॉमिक मास होगा, ठीक है। और इसी तरीके से वी हैव गॉट some mass differences. Okay, so we were talking about isotopes and elements. Isotopes. Okay. So elements are basically neutral, and they are the species of atoms having the same number of protons in the atomic nuclei and equal numbers in electron in orbits, which actually equal protons and electron charges in any atom. Isotopes are different forms of atoms. They have different number of neutrons. Okay, now number of neutrons. Isotopes have different number of neutrons. Elements have same number of neutrons. Can have same and different too. Atomic mass. Isotopes' atomic mass can be calculated by adding the masses of protons and neutrons, while elements' atomic masses and relative abundance of isotopes of the chemical element is used to calculate the atomic mass of an element. So this is basically not a work of a single day. We have to get into the depth of each and every element that is being discovered. What if I say that I have discovered a new element of phosphorus and a scientist from UK also say this? So now, after confirming both, we are going to relate both atomic masses, and then that relative atomic mass answer will be used as the atomic mass of that element. So it is not just the work of a single day. Single information about any element is a lifetime work. Okay, so we are starting the new topic called electronic configuration. So electronic configuration is basically the arrangement of electrons around the nucleus in the various shells and subshells according to their increasing energy level. As I was showing you that in the atom there is a central part called nucleus, and there are energy levels around that nucleus. So they are the shells actually. So scientists say that the energy level which is near to the nucleus is the inner shell and the first shell, and this shell is known as the K shell. The energy level which is a bit beyond the first one is the second shell, and it is known as K, while the third one is M and the fourth one is N. The energy level K has got the lowest energy, while the energy level N has got the highest energy if we compare KLMN. So these are the orbits, these are the places where actually electrons live. Okay. So distribution of electrons, you can see here that if we talk about hydrogen, the symbol of hydrogen is H, atomic number 1, proton number 1, there are no neutrons, number of electrons 1. So where will this one electron go? It will stay in the K. Okay, so this is actually the electronic configuration of an element. I have given the whole chart of first 18 elements. Please go through it and we'll discuss if you didn't get any. There is a capacity Allah Ta'ala has given to each and every shell. K will only retain 2 electrons. This is the rule of an atom. So see, K has only 2 electrons. This is a rule that L will only retain 8 electrons. So what will happen when we will have another one? So that another electron will move to the next shell called M. So there are rules that K will only retain 2 electrons. उसमें capacity ही उतनी है, ऐसे ज़्यादा capacity नहीं है, जगह नहीं है, It is out of space. L will retain 8 electrons, M will retain 18, and the cycle goes on. So this is basically the arrangement of electrons, or we can say accommodation of electrons inside the atom. Okay, so how do we represent it? That okay, there are 10 electrons. How will I make it? I will make it like this. See, I will make 2 electrons in the K shell, here, here, and here, and then the rest 8 I will make in the second shell, that's L shell. So this is how we diagrammatically present it. This is called Rutherford and Bohr diagram, and this is how we write it, KLMN, right? And this is how we make diagrams of it. So there are, you can say, in periodic table, rows, horizontal, vertical columns are here. What are they? Read about it. It is clearly mentioned in your book, and I want you to read about it. And I will really love it if you read all the things I have tried to give you, the knowledge I have got from my site to you. If you read it from the book or Google, I will really love it. So thank you so much, Jazakallah. I'm not so well today, so pray for me too. I love you all. Allah Hafiz.